Okay, welcome to 6.3 continued / 6.4 homework. Let's see if I can zoom in enough to make this. Oh, we don't need to do those. All right, so you only have to do the highlight part. So I'll do, I don't know, I'll do 7 just because it's right here. So it says, draw in the line of reflection that would need to be used to reflect P onto P1. Then write the equation. So we did this in class today, okay? So let me see if I can zoom in just a tad more. Is the light helpful? Actually, I think that's better. Okay. So, P to P1. There we go. I'm going to start out by connecting these with a line. Okay. Because remember, the line of reflection is going to be perpendicular to this line. It's going to be perpendicular to this line. So we're going to find the slope of this line, which is, I don't know, it looks like I go up 1 over 2, up 1 over 2. So up 1 over 2, so I have 1/2. Okay. Or if you did if you go all the way up, it'll be over 2, or sorry, up 2 over 4, which is the same thing. All right. So I need my line of reflection to be perpendicular to that. So we're going to flip it and change the sign. So flip it, so I get 2 over 1 and change the sign, which is just equal to -2. You can leave it over 1 if you want. Okay. I need to find the center of this line because these points have to be the same distance. So the middle of my line, right there. Okay. That's the middle of my line. See how P1 and P are the same distance away from there? Then I'm going to use my slope. So my slope is -2 over 1, so down 2, 1, 2 over 1, down 2, 1, 2 over 1, down 2, 1, 2 over 1. You can go the other way, do the opposite, up 2, left 1, up 2, left 1. Okay. I'm going to draw in my line. Somewhat straight. There we go. So now you have to write an equation for your line, for my purple line. So you can do either point slope or slope intercept. I'm going to do slope intercept. My slope is -2. Then my y-intercept, my graph doesn't quite extend that far. If I were to extend it, this is 6, and so it's crossing at 7. So if you were to extend your graph, it crosses at 7. Oh, we did this one in class. Ha! Well, oh well. And then if you want to do it in point slope form, you could also do that. So my slope, and then you can just choose any point. So I'm going to do, I don't know. We'll do 2, 1, the point 2, 1. So I get x minus 2 plus 1, and that was using the point 2, 1. Okay, you could use any point on your line though for point slope. Point slope. Okay. Okay, so 8, you're going to do the same thing. 9 and 10, you're going to do the same thing. I'll go ahead and do number 10. Why not? Why not? Oh, hold on. Okay. So same thing that you're doing for 8 and 9. So I need to find the line of reflection. So I'm going to If you can figure out the slope without drawing in this line, that's fine. I just think it's helpful to draw in the line. I'm going to draw in the line. Okay. And find the slope of said line. This one's kind of hard to see on my document camera. But you go 1, 2, oh, it looks like it's going to be 2. 2. So it looks like I go up 2 and then over 1, and there's another point. So my slope oh, you can't see it. There we go. My slope is 2. I just made this one really small. So then my line of reflection is going to be perpendicular. So my perpendicular slope. You flip it. So instead of 2, it's going to be 1 over 2, and then change the sign. So -1/2. All right. So go ahead and find the middle of your line. I already kind of marked it. What? I shouldn't say the middle. Well, it is the middle. The point on your line, these are both the same distance away from, and that's right here. All right, so that's where our line of reflection is going to go through that point. And then we can go ahead and use our slope of -1/2. So I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Go the other way, up 1, 1, 2. Okay. They made this really small. This is like unnecessarily small. I mean, you can't tell because I'm really zoomed in right now, but it's kind of ridiculous. Okay, anyway, there's my line. So then we need to write an equation for that. Here, you can't even see my coordinate grid. This is my x-axis goes right along here. That's my x-axis. All right, here, let me draw in my y-axis. It's kind of hard to see. Okay, there's my y-axis. There we go. That's a little bit better. Okay. So my equation for this line, for my pink line, y equals the slope, -1/2, x, and then you need the y-intercept, which is 1, 2, 3, 4, 4 plus 4. Let me make sure that's right because this is really small. Hold on. Okay, yeah. Or you could write it using point slope. And you can choose any point on the line. But this one gives you the y-intercept, so I would use this one if I were you. Alrighty. So you're going to do the same thing for number 9. Then come down here. Let me zoom back out. Can we zoom enough to see the graph? Maybe. Let's see. Uh-oh. Uh-oh. Keep zooming out. Oh, that's as far as we're going to zoom out. Okay. Well, I'll do number 17. So it says find the slope between each pair of points. Then using the Pythagorean theorem, find the distance. Okay. So basically, well, we'll just do number 17 and we'll talk about it as we go. So they give you a coordinate grid. So if you want to graph your 2 points, you can. So I have -2, -3, -2. Oh my goodness, why is it making it so hard to see? Hold on. I'm drawing my axes because they're hard to see right now. Okay, there we go. Okay, that's better. So anyways, -2, -3, -2, -2, 1, 2, -3, 1, 2. Wait, what? -2, -2. Okay, and then my other point is 1, 1. 1, 1. Okay. So I want you to find the slope, so I'm going to connect these two with a line. Okay. And then you could count to find the slope. Looks like I'm 1, 2, 3, 4, 1, up 4, 1, 2, 3, 4, up 4, 1, 2, 3. Up 4 over 3 is what it looks like on my graph. Okay, if you use it using this slope equation, that's going to be y2 minus y1 over x2. You can't see what I'm doing. x2 minus x1. Okay, and then just substitute in. So I'm going to make, this will be x1, y1. This will be x2, y2. Okay. So y2 minus y1, so that's 1 minus negative 2, which is plus 2, over 1 plus 3. 1 plus 3. So you get 3 over 4. Is that what I said? That's not what I said. 1, 2, 3, 4. Either I graphed it wrong or I just did the math wrong. Hold on 1 second. I just did this wrong. I'm sorry. I'm sorry. Hold on. y2, 1, minus negative 3, so plus 3. I switched them. And then 1, x2 minus x1, so plus 2. So you get 4 over 3, which is what we got when we counted. All right, we went up 4, 1, 2, 3, 4 over 3, 1, 2, 3. So I'm going to go ahead and, I'm actually going to go ahead and draw that in. I went up 4 over 3, 4, 3. Okay, now you have a triangle, right? So now it's similar to what we've been doing at the beginning of our homework with the Pythagorean theorem. So to find the distance, we just need to find C. Okay, so remember your Pythagorean theorem is a squared plus b squared equals c squared. So remember, it doesn't matter which one is a, which one's b. I'm going to make 3 be a, so I'm going to have 3 squared plus 4 squared plus c squared, 9 plus 16. 9 plus 16 is 25. All right, and then you would take the square root. And you would get c, because these cancel out. You get c equals 5. So your distance is 5. Okay, so then you would do the same thing for number 18. All right. These guys, 1 through 6, I'm not going to go through right now, but that is extra credit. I made them extra credit. You can Google them. What is a quadrilateral, or definition of quadrilateral, and it will tell you. Definition of parallelogram, and it will tell you. Okay, you can look them up in a dictionary. Ha! Like any of you have dictionaries anymore. But anyways, if you take the time, you can get some easy extra credit there. All right, 7 and 8. We've done similar, but we'll make sure to go over them in class tomorrow. Let me see which one I want to do. 1 second. I don't think it matters. It doesn't matter. Okay, I'll do number 7. Zoom out just a tad for a second. Okay, so it says, use the center of rotation, point C. So C is going to be our center of rotation. I'll make it kind of blue. Okay, we're rotating around C. And rotate P around it clockwise 90 degrees. And then we're also going to rotate it 180 degrees. Okay. So there are actually a few different ways you can do it. The way I think, well, I don't know, it depends on the person. The way we've kind of been doing it is thinking about perpendicular. So if I'm going to rotate P, let me connect P and C. Okay. Okay, I can zoom back in on my graph now, can't I? Hold on. We don't need the words anymore. Okay. I'm going to rotate it 90 degrees clockwise, so we're going in that direction, clockwise. Well, that means that we're going to be creating a 90-degree angle here. If you want, you can use your protractor. I just think it's not the easiest way in the book, but you can use the protractor. So 90 degrees. Okay, you can use a protractor and a compass. But anyways, I think the best way is to go, okay, we're going to be making a 90-degree angle here because we're rotating 90 degrees. So I'm just going to find the line that's perpendicular to this. All right. So perpendicular line. So first we have to figure out the slope of this line. It is down 1, 1, 2, 3, 4. Negative 1 over 4. Let me do that one more time. Down 1, and then 1, 2, 3, 4. So negative 1/4. So my perpendicular line is going to be, flip it, and then change the sign. So it'll be 4 over 1, or just 4. All right? Four over 1. So I can just go up 4, 1, 2, 3, 4 over 1. Okay. Okay, and this is a 90-degree angle right there. Okay. Make sure they're the same distance away. So this point is 1, 2, 3, 4, and on the line. And this one is 1, 2, 3, 4, and on the line. So they're both 4 away and on the line. All right. So that is P1. Wait. Yeah, P1. Okay. Rotating 180 degrees. 180 degrees is just a straight line. Oh, I put that way too high. Hold on. Come here for a second. Rotating something 180 degrees. 180 degrees is a straight line. Oh, it's on the other side. This line right here is 180 degrees. So if you're rotating a point 180 degrees, you're rotating it along a straight line. Okay. So I'm rotating around point C. Okay. So I'm just going to continue this line. That will be 180 degrees. Just continue this line. Should hit like right there. Let's see. Okay. And then make sure it's the same distance away. 1, 2, 3, 4. 1, 2, 3, 4, and then on the line. So it'd be right there. Oh, sorry. Another way to do this is we just, am I going to go there? I think so. I'm going to go there. Is we just learned the rules of, actually before I do that, I want to attempt to draw a circle. So you see that these points are all the same distance away from point C. Oh, they're so close together. Did I just show you? Okay, let's see if I can do this. I'm going to use my compass. I'm going to draw a circle. Wait. Oh, this is really small. Okay. Ow. Why does it keep ending up smaller than I want it to? I'm going to fix it by hand. Come around, and then we should be coming. No, here we go. It's such a small space, my compass doesn't want to do it. Stay there. There we go, maybe. There we go, okay. Had to adjust my pencil in there. So this is my circle. Let me trace over it. Hold on. Pause. Resume. Okay, there. I traced over it in green. Oh, I erased part of my line. Sorry. There. So when I rotate around this, my center of rotation is C, which is right here. All of these points are equal distance. They're all going to be on the circle. So if I rotate any number of degrees around point C, it'll be on this circle. Okay, they're all going to be an equal distance from your center of rotation. It's called the center of rotation because it's in the center. Okay. I was going to go in a different direction, but I think I'm not going to. I'm going to leave you there. So go ahead and try number 8 by yourself. Okay, and then number 9, number 9, 10. I'll do number 10, just to go out of order. So for number 10, what is the equation for the line of reflection that reflects P onto P1? So we're doing number 10, P onto P1. What is the line of reflection that reflects P onto P1? That's the first thing we're figuring out. Okay, we've been doing this, right? We did this, I guess we just did this today in class. So I'm going to connect these two with a line, my P and my P1. Okay. And then the line of reflection, that's what we're looking for, is going to be perpendicular to that. And it's going to go through the middle. So here's my middle. The slope of this line is down 1 over 2. So negative 1/2. And so my perpendicular slope will be positive 2 over 1, which is just 2. Okay. So positive 2. So up 1 over 2. Sorry, up 2, 1, 2 over 1. Then we can go the other way down to, okay, so on and so forth. Oh, actually, I'm going to keep going so we can have a clear y-intercept. So down to there. Okay. And these guys make a right angle. They are perpendicular to each other. And this P and P1 are both equal distance away. Oh, sorry. P and P1 are both equal distance away from this point. Okay. So my purple line equation is y equals my slope, which is 2, so 2x, and then my y-intercept is negative 2. Okay, so that's A. I'm gonna make sure I'm right because that'd be awkward. Wait, what number am I doing? Oh, I'm doing number 10. Okay, no, I didn't mean to do number 10. Okay, and then B, what is the equation for the line of reflection? There shouldn't be an S there. Line of reflection that reflects P1 onto P2. So now we're looking at P1 to P2. Okay? This is going to help you out with number 9. So pay attention. Here we go. So I'm looking for the line of reflection. So first thing I'm going to do is just connect P1 to P2. Draw my little line in there. We'll do green. Connected. Boop. Okay, there we go. So then your line of reflection has to be perpendicular and in the middle. Okay, so find your middle point. Here's my middle point. They're both 1, 2, 3 away. 1, 2, 3, 1, 2, 3. They're both 3 away from that point. Okay. Some of you might already know it, and you're probably questioning if you're right or not. You are probably correct. Anyways, so then what line is perpendicular to this line? Just looking at it. It has to go through this middle point. What line is perpendicular? If you want to find the slope of this line is, I mean, you're going up 3, but then over 0. So your slope's going to be 3 over 0, which you can't have that. Okay, so your slope is, you can't have your slope, but you can just look by looking at the graph. What line is perpendicular to the line we just drew? This one. Okay, really any of these horizontal lines are perpendicular to the line we just drew. All of these horizontal lines are perpendicular to the line we just drew. Horizontal lines and vertical lines are perpendicular. Make that right angle. But we need the one that goes through the center. So for B, your answer is, if you write down the x-axis, that's fine. But really what I'm looking for, actually it's fine, is y equals 0 is your equation for that line, or you can just write x-axis. That's fine too. Okay. So number 9, you're gonna be reflecting over your axes. I'll give you a hint there. Okay. Cool. Woo! Moving on to the last part. Wait. Yes. Moving on to the last part. Where is it? Uh-oh. Hold on. Okay. So this last part, the last 4 problems, are using the rules that I gave you at the very end of class for rotating around the origin. Okay. For instance, I'm rotating point A. So point A is 4, 2, 1. Oh, you can't see me. Let me zoom out. That's good enough. Okay. Point A is 4, 2. 1, 2, 3, 4, 1, 2. There's point A. And I'm rotating it 180 degrees. And so if you look at your rule chart, that means they just both become the opposite. So they become -4 and -2. 1, 2, 3, 4. Wait, sorry. 1, 2, 3, 4. -4, -2. Okay. So all you're doing is just look at the chart that we did at the very end of class. And that'll help you with 12 through 15. Alrighty. That's all I have.